this lecture we will solve some more numericals of 2D elements. So let us see example number 15, what is given in the data. Find the center of gravity of a lamina shown in the figure below. Has been asked in GTU exams several times. Let us see what is the data, what is the figure. There is a figure like the cross section as shown in figure. Here it is, you can imagine x-axis. There will be a y-axis over here. Now if you want to divide this into equal parts, then this is the first part, which is triangle. Okay, this is the triangle. This is the part number 2, which is rectangle, and this is the part number 3, which is semicircle, which have to be cut out from the section. So part 1 will be triangle, which is positive. Part 2 will be square, which is also positive. But the part 3, which is semicircle, which will be deducted from the total calculation. Let us start with the triangle. Now what is given in the triangle, that what is area of the triangle? You can see this is the base of the triangle, which is equal to 200 mm, which is visible over here, and the height of the triangle is given over here, which is 100 mm. So area will be 1/2 base into height. So answer will be 10,000 mm square. Now what is the CG? CG of the triangle is somewhere over here. So now CG of the triangle is from the base, it is h by 3. You must know. So from the y-axis, this distance will be 2 times height by 3. Okay, from here it is height by 3, and from here it is 2 times height by 3. Now this is the height. Height means 200. So it means 2/3 of 200 will be 133.33 mm. Okay. So now what is y1 actually? Y1 means this CG, same CG should be measured vertically. So this will be 100 by 3, and up to bottom it is 200. So total answer will be 200 plus 1/3 of 100. So answer is 233.33 mm. So here it is y1. Okay. Now for the part number 2, square. Square of the CG, you must know that it is at the midpoint. So 100 mm from the left side and 100 mm from the bottom, as the height and width both are 200. So answer will be 100 mm for square x2 and y2. What is area? Length into width, 200 cross 200, 40,000 mm square. Last part, part 3, let us change the color. You must remember that 100 mm is the radius of the part 3, and the CG, formula of the CG will be, from the center it is 4r by 3 pi. So the CG y3 will be 4r by 3 pi, in which radius is 100 divided by 3 pi, so it is 42.44 mm. What is x3? So this CG from the y-axis, this is known as x3, which is equal to half of the diameter 200. So which is equal to radius 100 mm. So x3 equal to 200 by 2 equal to 100 mm. And what is the area of the semicircle? You must know, pi r square by 2, in which radius is 100. So pi into 100 square by 2, which is 15707.96 mm square. So these are the calculations as per our formulas. Very simple. You just remember this with the help of practice. Now finally we have to find x bar and y bar. So for that, what is the formula for x bar? a1x1 plus a2x2 minus a3x3 divided by a1 plus a2 minus a3. So all the values should be replaced in this formula, and you will get the answer as 109.72 mm. Similarly in the y bar, a1y1 plus a2y2 minus a3y3 upon a1 plus a2 minus a3. All the values calculated earlier are replaced in this formula to get the answer of y bar 165.24 mm. So this is the numerical number 1 for today. Let us see one more numerical. In this numerical we have to find the CG of this plane area. Just forget this y and x axis which is dotted. You have to draw x axis from the bottom of the figure of the section and y axis from the left side of the section. Here it is part number 1, which is rectangle, part number 2, which is triangle, and part number 3 is again subtracted semicircle. Dimensions are given to you as shown in the figure. Let us start with the part number 1, which is full rectangle. So for the area of the rectangle, it is 300 cross 400, because this width is 100 and the diameter, you can see from the figure, radius is 150, so diameter will be 300. So this total distance will be 300 plus 100, 400. So 400 into 300 will be 1,20,000 mm square. And where is the CG of the rectangle? It is at the midpoint. So from the extreme left, it is at the halfway, means halfway of the 400. So it will be 200 mm. And y1, what is y1? The same CG will be measured from the bottom. So 300 by 2 is equal to 150 mm. Let us start part number 2, triangle. For the triangle, area will be 1/2 base into height. So height is 300 mm and base is 200 mm. So it is 1/2 200 into 300, 30,000 mm square. What is x2? This is the center of gravity of the part triangle. This is the distance base by 3, which is 200 by 3. But to reach up to y-axis, this 400 should be added. So this is 400 plus this is 200 by 3. So 400 plus 1/3 by 1/3 into 200, which will give 466.67 mm. Similarly, the same CG, this CG up to bottom, which will give the formula h by 3, where h means height of the triangle, which is 300. So 1/3 of 300, it is equal to 100 mm. Now let us start with the part number 3, semicircle. This is the semicircle for which area is pi r square by 2, in which radius is 150. So answer will be 35342.91 mm square. What is x3 and y3? So now let us change the color. What is x3 for the semicircle and what is y3? x3 will be from y-axis to this point, means this 100 mm gap plus radius equal to 150. So 100 plus 150 equal to 250 mm. And what is y3? So this vertical distance is y3, which is 4r by 3 pi. So 4 into 150 by 3 pi, 63.66 mm. So similarly, part 1 and 2 and part 3, all the calculations are completed now. Now you have to replace this into the main formulas. Our formulas are x bar and y bar. a1 x1 plus a2 x2 minus a3 x3, a1 plus a2 minus a3. Similarly, for the y bar it is a1 y1 plus a2 y2 minus a3 y3 upon a1 plus a2 minus a3. In both the formulas, remember that part 3 is subtracted from the figure. As the part 3 is semicircle, so it is subtracted from the figure, so that's why it is negative. So by replacing all the values which are calculated earlier, we will get the answer of x bar as 254.36 mm and we will get the answer of y bar as 163.53 mm. So these are the values of x bar and y bar respectively. So these two numericals are very helpful to understand the phenomena of the center of gravity. In the next lecture, we will take some more special numericals regarding 2D elements, regarding cross-sectional areas, and we will find CG furthermore. So day by day, video by video, you will practice this numerical for the center of gravity. So make sure that students, you have to do practice and practice. Please ask me for any doubts. Let us conclude with this topic, with this video for today. And in the next lecture, we will conclude some more numericals regarding 2D elements. Thank you very much, students.